In this example, we want to consider a vector 2, 3 given with respect to a basis b. We want to convert this into the standard basis, rotate it 45 degrees counterclockwise in the standard basis, then move it back to basis b. Okay, so our translation matrix T that takes something in B and moves it to our standard matrix E is given by the matrix where the columns are the basis vectors in the in basis B. Okay, so this will allow us to take a vector, move it from basis B into our standard basis E. Now, how do we get something that's, once it's in basis E, we get it back to B? Well, we have to take the inverse. So T inverse from B to E is the matrix T that takes things in E and moves them to B. The inverse of this guy is 1 plus 1, so that's a half times -1, 1, -1, -1. So just the inverse of this matrix here. So if I take a vector v, 2, 3, the first thing I want to do is I want to change that to be from being in basis B to basis E. So I multiply that by T, B to E. So -1, -1, 1, -1. So when I complete this multiplication, this is in terms of E. Now, once I have that vector in terms of E, I want to rotate it 45 degrees counterclockwise. Now that matrix, if we recall, the rotation matrix for 45 degrees counterclockwise is cosine 45, negative sine 45, sine 45, cosine 45, right? So that's 1 over root 2, negative 1 over root 2, 1 over root 2, 1 over root 2. So this guy will be 1 over root 2, 1 over root 2, negative 1 over root 2, 1 over root 2. When I do all of this multiplication, this will be in E and rotated. Now, once I have something that's in E and it's been rotated, I want to move it back to basis B. So I multiply by this transformation matrix, so that's 1/2 times -1, 1, -1, -1. So this whole thing is the final vector. So I just need to complete all that multiplication. And so when you multiply these three matrices together, you end up with 1/2 times 2 over root 2, 2 over root 2, -2 over root 2, and 2 over root 2. still times 2, 3. So if we ever wanted to do this same rotation, but with a different vector, all we do is multiply by this matrix here. And in fact, if we were really being cute, we could cancel out the 2's with the 1/2 out front. But when we complete that, our final vector rotated is -1 over root 2 and 5 over root 2. And so that is our final answer.